Okay, so Precalculus 30, this is 6.1, number 7. And we're talking about identities, reciprocal quotient, and Pythagorean identities. A word problem here says this: when a polarizing lens, so your sunglasses, if you have polarizing lenses, when this lens is rotated through an angle of theta over a second lens, the amount of light passing through both lenses decreases by 1 minus sine squared theta. You don't have to know the science behind that. You just have to kind of get the background of the situation. So here's the equation that we're given. It's asked us to determine an equivalent expression for this decrease using only cosine. So an equivalent expression is not an equation. We're just asked to change this into to be written in terms of cosine only. So right now this is 1 minus sine squared theta. Is there anything that you see in there that can be transformed into being written in terms of cosine? Well, you could look at the 1, couldn't you? You could look at the 1 and you say, hey, I know what 1 is. 1 is cos squared plus sine squared. Okay. If you look at sine squared, I know what sine squared is from your Pythagorean identities. That's 1 minus what? Okay. We just had a break and everyone is a little, I don't know what's going on. Okay. So Pythagorean identities, remember that? Remember those? So what do we got here? Cos squared plus sine squared equals 1. Also 1 equals, 1 minus sine squared is cos squared. So you can rearrange those identities. So let's go back to the question. Number 7. So 1 minus sine squared, do you see that 1 minus sine squared is actually cos squared from the Pythagorean identity? So you could look at this 3 different ways, really. 1 minus sine squared, so cos squared theta plus sine squared theta equals 1. You could change this around to equal, hey, what is cos squared? Well, cos squared theta equals 1 minus sine squared. You see that? So you could go right from here to cos squared. You could also take a look at the 1 and you could change this. Now this is the long way, but this is really important. You could change the 1 into cos squared theta plus sine squared theta. And then what happens? Well, if you leave the rest of the expression there, look what happens. Those are gone and you're left with cos squared theta, right? So you could transform the 1 into this right here. Replace it and simplify. Or you could look at the whole expression and realize that this is a secondary sort of a secondary identity equation there. Now, the other one I said, you could take the sine squared theta and you could say, okay, well, I know also that sine squared theta is 1 minus cos squared theta. So you could change that one into 1 minus cos squared theta. You see that? And this is sort of the essence. This is the big idea here in chapter 6, is taking portions of expressions and substituting other identities, other things that we know that they equal, is substituting them and then simplifying. So what we have here now is 1 minus 1 plus cos squared theta when I get rid of these brackets. 1 minus 1 is 0. I'm left with cos squared theta. So any way you look at it, any way you substitute, you get cos squared theta as a simplification here. Okay, so does at least part of that make sense to you guys? For A? Yes? You don't have to do all 3 ways, but I need you to see that all 3 ways are possible. You could substitute different things into different parts of this expression. Okay. So B, what fraction of light is lost when theta equals pi over 6? So you could put theta in to right here if you want. that would be great. So cos squared of pi over 6. What is pi over 6 on the unit circle? What's cos of pi over 6 on the unit circle? Pi over 6 is 30, right? So 30. So if you're doing your finger thing here, it's 30. So what's it going to be? You take away this finger, cover it up. What do we got? Root 3 over 2 and 0.5 or 1 over 2. Root 3 over 2, 1 over 2. So cos is the first one or the second one? First one. So does that make sense that it's root 3 over 2? Okay, root 3 over 2. And of course that's squared. So We square it. So what does this expression actually equal when we put pi over 6 in? This is going to be 3 over 4. So what fraction of light is lost when the angle is 30 degrees? 3/4 of the light is lost. The amount of light passing through decreases by. So it's losing 3/4 of the light. So loses 3/4 of the light. That's what this means for B. Well, here's B. Okay? Questions? A is just cos squared there. Cos squared theta. Okay, so C, what percent of light is lost when theta is 60 degrees? Okay, so 60 degrees. Now, when you're graphing this, if you're graphing this, you should change this into radians because the graph will kind of work in radians. 60 degrees to radians is how many radians? Pi over 3. So 60 degrees is pi over 3 radians. What percent of light is lost when theta is 60 degrees? So you simply go ahead and do cos squared of pi over 3. And pi over 3 is, okay, here's the 0, here's 90, here's 45, here's 60. So it's going to be, the coordinate's going to be 1 over 2 and root 3 over 2. So it's 1 over 2. So 1/2 squared. So it looks like that's 1/4 of the light. So in C, it loses 1/4 of the light. Now it says what percent of light is lost. Loses 1/4 of the light, which is 25%. Okay, so loses 1/4 of the light, which is equivalent to 25% of the light is gone. All right, that helped for 7? Okay. So you do have to know your unit circle. You have to have at least, you should have that first quadrant memorized. Use the finger thing if you want. You know, cover up the angle, and then it's always over 2. So 1 over 2, and anything with 3 is always root 3. So 1 over 2, root 3 over 2. 45 is root 2 over 2, root 2 over 2. And then this one is root 3 over 2, and 1 over 2, and so on. Is that right for you guys? Yeah. Well, you see that? Okay, good. Okay, that's 7.